PTR Professor Math videos. We're going to, I want to do some practice videos on plugging and chugging. These are the best videos that I have found. These are the best way to practice algebra. When I discovered how valuable these were to me, I practiced hundreds and hundreds, if not thousands of these. So I'm going to pass this little bit of wisdom on to you. When you can practice these, the advantage of these is they give you the ability to come up with your own equations. You can invent your own equations and practice these till the cows come home. Have your calculator with you and test. So we're given the fact that x equals 6 in this, right? So what if we're given an equation of 28 divided by 2x? The idea here is we plug in 6 everywhere there's an x, and then we solve the equation. And what this does is it gets us familiar with working with algebraic equations and different variables. So this is simply, this becomes 28 divided by 2 times 6, which is 28 divided by 12. We always want to work from left to right, and we'll learn how to do order of operations and all kinds of things like this. 28 divided by 12 is simply that, 28 divided by 12. Now they're both even, so we know we can take out a 2 at least, but is there a better number to take out than 2 with 28 divided by 12? What we do is we find the factors of 28 and 12. In this instance, 4 is going to come out of 12, and so is it going to come out of 28. 7 times 4 is 28, and 4 times 3 is 12. So we take a 4 out of 28, that leaves us a 7. And we take a 4 out of the 12, and that leaves us 3. So this is 7/3. We recognize immediately that it is an improper fraction. The numerator is larger than the denominator, right? So we know we can divide the denominator into the numerator. 3 goes into 7 how many times? 2 times. 2 times 3 is 6, so that leaves a 1 left over. You bring down the denominator, so this answer is 2 1/3. That's how that works. It's fun to do, to be able to practice things. And when you look at it, it's really not that complex of a mathematical equation. Whoop, I erased my x equals 6. X equals 6. What if we're given an equation of 4x minus 4 over 5? Now we're dealing with a variable. We have it divided in a fraction. We have a numerical coefficient with a variable subtracting a numerical coefficient. The number in front of the variable is called the coefficient of it. We simply plug in 6 where the x is, so this becomes 4 times 6. This is the way the books will write it a lot. That just simply means multiply divided by 4 over 5. Then we simply do the operations. 4 times 6 is 24, minus 4 over 5. 24 minus 4 is 20 over 5, and 5 goes into 20 4 times. So we're beginning to get used to doing the different equations, how they work, how to do them, etc. And this is valuable practice. We have to, mathematics is one of those subjects where you have to do in order to understand. It's just that simple. You just have to crunch a lot of numbers and do a lot of equations, and the more you do, the better off you're going to be. Now we're given a number 3, then a parenthesis, x plus 5 minus 3. When we see this form, in order of operations, anything within the parenthesis is automatically done first. The grouping symbols are a red alert to your mind that this has to have the priority of attention. So we solve this part first, and then we continue on with the operations, always working from left to right. So first we fill in 6. We put the 6 in with x minus 3. Now we can solve what's in the parenthesis. 3 times 6 and 5 is 11 minus 3. And then 3 times 11 is 33 minus 3, so that becomes 30. See, that's not that difficult, even though we're looking at an equation that looks somewhat difficult. It's really not that hard. What if we give something similar to this? If we're given 3x minus 3 times x, instead of a numerical coefficient in front of the parenthesis, what if we're given the x here and the x here? Now we have 2 blanks to fill in, right? And you just simply plug and chug. This becomes 3. Now we're keeping the parenthesis, so I like to do a little bracket. 3 times 6 is the same thing as the parenthesis, minus 3, and we know we're going to multiply that by 6. So now we've got the x filled in. Now we do the operation from left to right. 3 times 6, and always in the parenthesis first. 3 times 6 is 18 minus 3. We're keeping our parenthesis, and that'll be times by 6. We multiply by 6. We don't have to put a dot in between it. Whenever there is a number next to a parenthesis, that's going to be multiplied into it, unless there's a specific operation otherwise indicated, like in this instance. This part's multiplied, but this part is subtracted once we solve what's in the parenthesis. In this instance, we don't have this sign of subtracting something or adding something or dividing something, so we know this is going to be a multiplication. That's how to read the algebra. 18 minus 3 is 15 times 6, which is simply 90. You see how that works? It's kind of nice to be able to practice equations that give us a familiar feel for solving. We get used to looking at equations with variables. We get used to doing equations with variables and all kinds of different operations, which is very important because if nothing else, algebra is going to keep us hopping with all kinds of equations, because after all, the world is complicated. There's a lot of ways we can discover the world, as it were. What if we're given, and all these equations, incidentally, none of these are given to us for just busy work. No, these equations occur in real situations in life. This isn't just to keep us learning math and busy work. All of these will eventually get to be applied. So let's say we're given an equation x plus 1 divided by 3 minus x. Now when you get a fraction that has a variable in both the top and the bottom, or when you get a fraction that has a double operation in the numerator, we're going to add 1 to this x, and you get the same thing in the denominator. In this instance, we're going to subtract x from 3. Just do one part of the fraction first, the numerator, the top part, and then do the bottom part. It's really not that difficult, I promise. So this becomes x is 6 plus 1, and this is 3 minus x is 6 minus 6. And then you carry out the operation on each part of the fraction. 6 plus 1 is 7, and 3 minus 6 is minus 3. Because 3 minus 6, we turn subtraction into addition. We add the negative. It's the same thing. Since the 6 has a larger value than the 3, we notice the difference between 6 and 3 is 3, but the 6 is the larger number and it has a negative, so we know our answer is going to be negative. And the answer is negative 7/3. There's really not a lot to that, is there? That's really, honest to goodness, kind of nice and easy. And I like it when math is nice and easy. All of these properties, all of these ways of operating with numbers in various multiply, divide, add, and subtract is designed to make it simple for us. It really is. Now let's say we're given, now if this will write, let's say we're given that f is 3 and k is negative 2. Now, again, we're just dealing with variables, letters that represent numbers. It's not a big deal. And we're given the value of these numbers, which is kind of nice because then we can just subtract, add, multiply, divide, and put the numbers into our equation. But you notice now we're getting into algebra, aren't we? And this is why we want to familiarize ourselves with the process and what the equations look like and how to manipulate them so that we can say, well, what do we do now? What do we start by doing, etc. We get that through practice. This simply becomes 28 minus k. K is negative 2. Now watch this. 28 subtract k. K is negative 2. We do 28 subtract, we're subtracting a negative 2, that's important to keep track of, over f. F is simply 3. So that's how you write that. And now we have our old friend, the double negative, right here. And the idea with the double negative is you negate the negative. So 28 and 2 is simply 30 over 3, and that simply equals 10. 3 goes into 30 10 times. Once you learn the order of operations, once you recognize some of the properties of how to manipulate and work the numbers, and then all it does to get more complicated is it gives you more ways to do more operations in an equation. And that's actually what makes the algebra seem difficult. We're given 4k over negative 4f. Now this is a beautiful looking algebra equation, isn't it? Okay, yeah, maybe it's not beautiful, but it's a typical looking one. We put in the, we fill in what it is. 4 times, remember, just a coefficient next to a variable, or if it was a variable with a variable, always means multiply. They will distinguish between adding, subtracting, and dividing. And actually, we are going to divide a numerical coefficient and a variable by a negative numerical coefficient and a different variable. K in this instance is negative 2. And we have negative 4 times f. F is 3. And now you can see that's really not that difficult, is it? 4 times negative 2 is negative 8. Negative 4 times 3 is negative 12. Now we have a fraction that has a negative here and a negative there. An even number of negatives mean it's going to be positive. So this is simply 8/12. We can see that both the numerator and the denominator are even, so we know we can reduce this fraction. They both can be taken out with a 4. If you take 4 out of 8, you're left with 2. And if you take 4 out of 12, you're left with 3. So the answer to this is 2/3. And that's as easy as it gets. There's nothing overly complicated with this. What if we're given 2f minus 1 and 3k plus 3? This is a typical way that an algebra equation works. We fill in the blanks. 2 times 3 minus 1 over 3 times negative 2, k is negative 2 here, plus 3. It's that simple. 2 times 3 is 6 minus 1 over 3 times negative 2 is negative 6. A positive times a negative is a negative, plus 3. 6 minus 1 is 5. Negative 6 plus 3. You're starting to the left of 0 in the negative territory at negative 6. You're going to come back to the right just 3 units, so that's going to be a negative 3. 6 is the larger number of this between 6 and 3, and it has the negative. Therefore, the answer is going to be negative. You can leave this with the negative in front of the 3. It doesn't matter if the negative was in front of the 5. But what I like to do is I like to put the negative out in front. Negative 5/3. And you can see it's an improper fraction. So if you want, this is a good enough answer. This will work. You can't be marked wrong with this. But if you want to do 1 2/3 and keep your negative, but that's a negative 1 2/3. 3 goes into 5 once. There's a 2 left over. You put that in the numerator and you bring your denominator over. Negative 1 2/3. That's not too tough of a practice session, is it? Not too bad. All right, let's do a few more. I've got about 10 minutes left. I'm going to try to crunch a bunch of these for us as fast as we can. Oh, let's say, looks like I'm getting into a new group here. Let's say y is 8 and r is 4. See, you'll notice it doesn't matter what the variables are anymore, does it? It really doesn't bother you. They're just letters that represent a number. In this instance, y is going to represent 8 and r is going to represent 4. So the question is, what is the equation? Y plus r divided by 3. See, there's our algebraic equation. 2 different variables, plus we're dividing by 3. That doesn't freak you out anymore because we know a variable is simply a number. We plug and chug. This becomes 8 plus 4 divided by 3. 8, 9, 10, 11, 12 divided by 3. 3 goes into 12 4 times. Not too tough, is it? What if we're given r times y, times y squared minus r squared plus 6. Now you look at that and you're starting to go, whoa, that's getting a little technical and complicated. No, it's not. We know the r is going to be multiplied by the expression in the parenthesis. We know the expression in the parenthesis, because of the grouping symbols, is the priority part of this equation. After we have solved what's in the parenthesis, and after we have gone from left to right, multiplying the result here by this variable, then we come over to here and add the 6. It should work out fairly easy, right? Let's plug and chug. R is 4 in this instance. So we have 4 times y is 8 squared minus r squared, which is 4. So that's 8 squared minus 4 squared, parenthesis, plus 6. So we solve what's in the parenthesis. We do the exponents. 8 squared is simply 8 times 8, right? So 4 comes along for the ride for the moment. We don't want to forget our friend 4. 8 squared is 64. 8 times 8. 4 times 4. 4 squared is 4 times 4. That's 16. And then we're going to add the 6. First, solve what's in the parenthesis all the way first. So the 4 continues coming along for the ride. And 64 minus 16. I should know this by heart by now. 48. 48. 48, not 46. Plus 6. Now 48 times 4 is 192 plus 6. You notice how we've solved everything in the parenthesis first, then we did the multiplication next. This is the proper order of operations. Multiply and divide before you do add and subtract. Finally, we get to where we're going to add the 6. That simply equals 198. That wasn't that tough to do, was it? It's just a matter of systematically applying the rules, solving what's in the grouping symbols first, multiplying and dividing next, and then adding and subtracting, and you can solve pretty much any equations with the proper order of operations. It's really nice to be able to know that, to know we have the power and the capability. Now you remember what absolute value was. The absolute value bars. We've got absolute value of y plus r. And I make them a little extra long. Minus 6. Absolute value is simply telling you how far away from 0 the number is. Whether you go to the left in negatives or to the right in the positive integers, it doesn't matter. The value is how many places away. So let's plug and chug. Y and r. The absolute value of y is 8 plus r, in this instance plus 4. We want the absolute value of that and subtract 6. 8 plus 4 is what? 12. The absolute value of 12 minus 6. We know the absolute value always has to be positive, so the absolute value of 12 is simply 12, subtract 6, equals 6. So see, absolute value problems really aren't that difficult at all, are they? That was actually embarrassingly easy, right? You can see that. See, this is where you gain your confidence. You begin building your confidence as someone throws all kinds of equations at you to try to stump you and fool you. You don't have to. How much time have I got? I've got time for one more. Let's say y times r minus 3 plus 8. Now here's a great algebra expression with a couple different variables and a couple of interesting different operations. When you see a variable or a number in front of a grouping symbol without any add, subtract, multiply, or divide, it is going to be multiplied. We know the order of operations says do what's in the parenthesis first always. So let's do that. First we plug and chug. Y is 8 times r, which is 4, minus 3 plus 8. Plus 8. So now we've plugged and chugged. We solve what's in the parenthesis first every time. We have 8s along for the ride for the moment. 4 minus 3 is simply 1, and we're going to add 8. Now here we do the multiply and divide before the add and subtract. In grade school we were taught add and subtract first because that was probably the simplest way to teach us, right? Here we say in algebra, trigonometry, calculus, and from now on, multiplication and division is more important. So we do that first. 8 times 1, 8. Right? 8 times 1 plus 8, which is simply 16. So this gives you the idea of how to do equations, familiarize ourselves with these equations. As we practice these by the hundreds, you will be astonished at how much confidence you have doing algebra, and you will be amazed that when some kind of a new idea shows up in the math, you're not spooked. You see that and you say, well, I know what to do here, I know what to do there, I know what to do here, and before you know it, you're solving equations all over the place, and this is what makes math so fun. Invest a little time now, and we will be solving all kinds of problems. So that's fun stuff. So anyway, that's what I wanted to tell you today. Looks like I'm out of time. So Happy calculating. Have a great life. And I will see you in the next video.